Okay, so I was working on a plane. I will show you the plane later. It is a very big plane on which I had a great idea to put a 6S iFlight Zingy motor. But then I came to a sudden realization that I don't have a 6S ESC. I thought, okay, I have this 6S ESC, which is supposed to be a 6S ESC, but the problem with it is, firstly, the buck converter which I soldered externally is only 4S capable. Secondly, it's a 30 amp ESC. That Zingy motor is a 40 amp, like it requires a 40 amp ESC. So I'm like, okay, I have another 40 amp ESC, but it's a 224S ESC. So now comes the question of, should I buy a new ESC or should I modify the old ESC? So I'm like, okay, I will open both of the ESC. So this is the 30 amp ESC. This is this one from Ready to Sky, 30 amp 226S, and like ignore this part. This is the buck converter I soldered in. But if you camera focus, yeah. So if you see, there is not much on this ESC. Just two ESR caps, some input, one microcontroller from some random company, most likely one MOSFET driver. Like, I have not looked them up. I'm just like, oftentimes just by reading the part number you can judge whether what is an IC. For example, if you see its part number is something 51. I will just, yeah. So Nuoton K51. Whenever the part number has 51 in its name, it is generally a 8051. And it's known fact that ESCs majorly run on 8051 architecture. So yeah. And the second IC, most likely, since you can see 3 capacitors and 3 resistor like diodes coming out of it, so it's part of most likely a bootstrap circuitry. So most likely that's a MOSFET driver. And then on the other sides we have the actual MOSFETs. So like a pretty simple ESC without a BIC. BIC is battery eliminator circuit for those playing along at home. So yeah, I totally did not pick this lineup from David Jones, but okay. So yeah, so now I opened the 6S ESC, the 4S ESC 40 amp capable, to see what is the difference. Of the start, if you see on this side there are more number of MOSFETs explained because it's a 40 amp ESC, that is explained by that fact. But on the other side, if you see, we have the similar two chips. Again, some 8051 based microcontroller from Nuvotic, same as the one in that, and the same MOSFET driver IC. I think I've not checked it. But apart from that, we have these two tiny components, but pretty much it is similar to this one. Like, this is a side-by-side comparison. So if you see, they are pretty much similar. Like, the only difference is these 3 ICs. And guess what are these 3 ICs? So camera focus. Yeah, so if you are able to see the part number, it's a 7805. And that explains the fact that this one is capable of a 5 volt 3 amp ESC. So 1 amp per 7805, so 3 amps. Now, if you open the datasheet of a 7805, it is capable of up to apps max VDD of 35 volt. So technically, this ESC should be capable of 6S and not limited to 4S. And that fact I tested using my power supply, which is just over here. So yeah. And the ESC did not blow up and the motor was also working. So that again confirms my theory. So what is happening most likely in both of these ESCs is these two small regulators. One of them is a 7812 and 7805. So the VDD is being converted to, the VIN is being converted to 2 voltages, a 12 volt rail and a 5 volt rail. Maybe the 5 volt is being converted from the 12 volt rail. I'm not sure because we don't have the circuitry for it, but I think you will be able to find it online easily if you are that curious. So since these are 6S capable, this is also 6S capable, the only fact or the only concern that comes up is that the heat dissipation from the 7805 would be too much. So the simple solution to that would be, like, if I don't want to buy a new ESC, just desolder the 5 volt wire, which you can see I did it here. So there is that 5 volt pad, if I can point to it. Okay, so that is the 5 volt pad. You can see 5 volt written also, I desoldered the red wire from it. I soldered 2 new silicon wires. I soldered in a buck converter, one of the cheap buck converters that was readily available with me. And then I set its output to 5 volts and then passed that to the red wire that was already going to the ESC, already coming out from the ESC. So now my ESC is technically 6S capable. You don't have to buy a new ESC. These ESCs by default support up to 6S. In fact, they can go up to 8S also, because if you consider their data sheet, the LM7805 can go up to 35 volts, and that is like more than 8S if my calculations are right, at least more than 7S. So you can easily push them up to 7S also. Just keep in mind the current max they can give is 40 amps, and the MOSFETs may have a breakdown voltage. I am not sure. We'll have to look up the data sheet as well. But again, more than MOSFETs generally have more than 24 volts only, these high current MOSFETs. And I tested it with 6S, at least it worked. So it did not blow up. Yeah. So that's it. So that's how you convert a 6S ESC, a 4S ESC into a 6S ESC if you don't have spare parts. If you don't want to buy a new ESC and you have spare parts at home. So yeah, thanks for watching. And yeah, this is the plane, Olympics 2400. Fabulous plane is what I've heard. I personally have never flown it. It's again a donation from someone. Somebody crashed it and I just repaired it with some fiber tape. Basically some glass fiber and some Fevikwik and some 3D printing and designing. And yeah, that is a 6S motor from iFlight. Don't question me why did I put a 5-inch motor and not a 7-inch motor. Just me being me. And yeah, this is the plane. Someday it will fly. But let's fix its ESC situation first.